Okay, so today we're going to be learning function operations. So remember, we're in the unit of solving, amongst some other things that go along with solving. So today we're going to be dealing with function operations. So what we're going to be given is we're going to be given multiple different functions, and we're going to be asked to perform a certain operation. So operation means addition, subtraction, multiplication, or division. So we're going to be given two functions. We're going to ask to either add them, subtract them, multiply them, or divide them. And then we're learning something new today, which is function composition. So these are the 5 operations we're going to be performing on our functions today. So this is the notation we're going to be seeing today. We know how to add functions. We know how to subtract functions. We know how to divide and multiply functions. But we're going to see new notation today. So this is how addition looks. In parentheses, we have two different functions, first of all, f of x and g of x. Two different functions, f of x and g of x. With addition, you'll see it written 2 ways. If we have in parentheses f plus g of x, you'll just split it apart. That's all this means is f of x plus g of x. Does everybody see how we're adding function f? Hold on. We're adding function f plus g, and they're both functions of x. So we can just split it apart, and I always rewrite it like this, f of x plus g of x. Does everybody see how it's just splitting it apart? They mean the same thing. You'll see it written both ways. All right, subtraction. Same thing as addition, just subtraction. If we have f minus g of x, we're taking function f, we're subtracting it from function g. They're both functions of x. We can just rewrite it as f of x minus g of x, and then actually do that. So that's subtraction. Addition, subtraction, now multiplication and division. Questions on how this notation is written? Doesn't scare you? Shouldn't. Okay, good. Awesome. Can I go forward? Not quite yet. Sorry. Now, as you do this, we have to just keep in mind, we have to be really careful with subtraction, because we're subtracting all of g of x, right? And a lot of you missed out on this text. We had 2 functions. I had you subtract them, and we were subtracting complex numbers, but you only subtracted a piece of the complex number. So we have to be careful with subtraction. Okay, so multiplication and division. With multiplication, you'll see it written like this, f times g, and they're both functions of x. F times g of x. You can just split it apart and write it as f of x times g of x. Same pattern that we saw with addition. And with division, same thing. If we have function f, we're dividing it by g, and they're both functions of x. We'll just split it apart and do f of x over g of x. So everybody, as you can see, we're pulling these apart. We're rewriting them just because it's an easier way of seeing it, and then we'll actually just perform that operation. So hopefully notation doesn't scare you too bad. Now keep in mind, guys, order matters. So if they did g times f of x, you would do g of x times f of x. Just do it, split it apart how you read it, straight across. Now we're going to ask to find the domain as well today. So remember that domain is x values. How far left and right is our function growing? What's allowed? Now today we're going to be restricting our domain because we want our domain to only contain real numbers. So with domain, what we have to think about is where do we run into problems? So we'll restrict the domain so that we do not have problems. Well, here are the 2 types of problems we can run into. You cannot have a denominator of a fraction be equal to 0. So if you have, for example, 3 divided by 0, this divided by 0 is bad news. 0 can be on top, though. Can't be on bottom. This would be bad news. So if we were doing something like f of x divided by g of x, we know that the bottom can't be equal to 0, so we would say g of x cannot equal 0. And we would actually figure out where it's going to be equal to 0 and say, okay, our x values cannot be this value because then our bottom would be 0. So that's what, does everybody understand why this is bad news? If you try to type that into your calculator, 3 divided by 0, it will say error. It's because you can't divide by 0. Any questions on the first problem we could run into with domain? Okay, second problem. This one we haven't gotten way in depth into yet. So you're going to have to, this is learning it kind of new for the first time, kind of. We all understand that if we take an even root and we have a negative underneath, it's an imaginary root, right? Like I said, today we only want real solutions. So a problem would be having a negative under an even root. So we cannot have a negative number under an even root. So our number under the root has got to be greater than or equal to 0. So that's how we'll restrict the domain with something like this. So it can't be a negative number. So our underneath our root has to be greater than or equal to 0. It's okay to have a square root of 0. Square root of 0 is just 0. That's why you can have it equal to 0, but it can't be less than that. It's got to be greater than or equal to 0. So the number underneath has got to be greater than or equal to 0. Those are the two problems that we'll restrict our domain with. Does that make sense, everybody? So we're actually not going to necessarily, well, yeah, so we'll be restricting our domain, stating it, and we'll do that with these two issues. Okay, any questions on that? Can I go on? Are we all okay? All right, let's start our first example. So you can just look up here. If you don't want to take notes on this, that's fine. If you just want to look, ask questions, that's fine with me. So let f of x be x plus 3 and g of x be negative 2x plus 2. Does everybody see how we have two different functions, f of x and g of x? Okay, so now we're asked, find f plus g of x, and then we're going to state the domain. So we know that f plus g of x simply means f of x plus g of x. Any questions? All right, so now just put it in. We know what f of x is. F of x is x minus 3. So we're going to be x plus 3. So we're going to be doing x plus 3, and then we'll be doing plus g of x. Well, what's g of x? We were given g of x, negative 2x plus 2. So we're doing f of x plus g of x. G of x is negative 2x plus 2. And then we'll simplify it. We'll combine like terms and simplify. So let's combine like terms. 1x plus negative 2x's is how many x's? Good, negative 1x or negative x. I just combined x and negative 2x. Do you have questions? All right, and then 3 plus 2 is 5. So we have negative x plus 5. Looking at this, do we see any potential problems? Is there a fraction? No, there's not a fraction, right? So we're not going to have a denominator of 0. There's no fraction. Is there a root in my answer? No. So our domain doesn't need to be restricted. We can plug in any number we want. So our domain for this one is all real numbers. And this would be our final answer. Any questions? Right. Well, there was no negative, right? So we're just combining like terms. So positive 3 plus 2 is positive 5. Yeah. Good question. All right. Let's do another one. This one, f of x minus g of x. So figure out what is f of x? What's f of x? So we have x plus 3, and then we're subtracting g of x. This is the one we have to be careful on. This is the one that 80% of students miss, and it's such a shame. Such a shame. So we're subtracting g of x. So since it's subtraction, I'm going to put it in parentheses. So we've got to subtract all of g of x. What is g of x? Negative 2x plus 2. Any questions on why I put it in parentheses? Okay, so now let's go through and simplify this. Okay, now I'm going to rewrite this as a negative 1 in front, and then I'm going to distribute that through. Negative 1 times negative 2x. Positive 2x. Very good. Now I have to distribute it through here. This is where people miss. Negative 1 times positive 2 is negative 2. Does everybody understand that? Then I just dropped down the front thing because we weren't changing the sign here. So we have x plus 3. And now, because I distributed negative 1 through, we can simply combine like terms from here. So let's do that. We have 1x plus 2x's. How many x's? 3 x's. Very good. And then we have positive 3 minus 2. Positive 1 plus 1. All right, let's restrict our domain where necessary. Do you see any problems? Is there a fraction? No? So we're not going to have to worry about any dividing by 0. Is there a root? Nope. So our domain is okay. You can plug in anything. It's all real numbers.
So we don't need to get the x by itself.
We're not solving. We're just doing f. Good question. So we're not solving in this one. We're just doing f of x minus g of x. This is our answer. So there's no equal sign here, right? So we wouldn't be solving. So good question. That's actually a really good question. That would be wrong because that's not f of x plus g of x. And there's no equal sign. You'd be magically floating one in. Does that make sense? Okay. All right. Any questions on this? No? We're all good. Okay, let's go to another example. So same two functions. Now we're going to do f times g of x and state the domain. So f times g of x. Well, remember that f times g of x just means f of x times by g of x. So now let's just put it in. What is f of x? X plus 3. I'm going to put it in parentheses. We're timesing that to g of x. So that's negative 2x plus 2. Does everybody see how that's f of x times g of x? It's our function f of x times by our function g of x. And then from here, we've got to double distribute. X times negative 2x is negative 2x squared. X times positive 2 plus 2x. Now I've got to distribute positive 3 through. Positive 3 times negative 2x. Good. Negative 6x. Positive 3 times positive 2 plus 6. All right, let's combine like terms here. So combining like terms, we have negative 2x squared, no other x squares. Then we have positive 2x's minus 6x's. How many x's? Minus 4x's. And then we have our plus 6. And we cannot combine any of those things, right? They're not like terms, so we can't combine them. All right. So then from there, let's find our domain. So do you see any problems? No? No fractions, right? There's no fractions. So we're not going to be dividing by 0. There's no roots. So we're not going to be having a negative under a root. So our domain is all real numbers. You can plug in anything. Do we have any questions? If you graph that, you could look and see where your function's growing from left to right, but it is all real numbers. It's negative infinity to positive infinity. So it's easier when you're dealing with just domain to say, is there any problems? If not, we're good. All right, let's do f divided by g of x. We know that this is simply f of x divided by g of x. So that's going to be f of x is x plus 3. G of x is negative 2x plus 2. Right? Everybody? Okay. So then you'll look at that and see if they simplify, and they don't. So they don't simplify, nothing simplifies. So that is f of x divided by g of x. But now we need to see also part of our answer is going to be the domain. Do you see anywhere we might potentially have a problem? We can have negatives in the bottom, but we can't have a what in the bottom? A 0, right? So you're saying that this bottom part cannot be equal to 0. So you're saying if we say, okay, so negative 2x plus 2 cannot be equal to 0, right? Right? Okay, so now let's solve for x. Let's solve for x. So what should I do first to solve for x? Minus 2 from both sides of the equation. So we have negative 2x on the left. Those add up to be 0, which is equal to 0 plus negative 2 is negative 2. Solving for x, we'll divide both sides by negative 2. So that divides out to be 1. So we have x is equal to, what's negative 2 divided by negative 2? 1. Now remember this was cannot be equal to. Cannot be equal to. So you're saying x cannot be equal to 1. So our domain in this one will be, well, that's our answer. But our domain is x cannot equal 1. Or else, guess what happens? The denominator is 0. Watch. Let's plug in 1 and see what happens. Negative 2 times 1 is negative 2 plus 2 is 0. Do you see why we have to say x cannot equal negative 1? Do you see how if we plugged it in, it would be 0? Do you see how I solve for it algebraically? You all understand that? I'd set the bottom equal to 0 and solve. That is where your function will be equal to 0. Does that make sense? That would be a problem. Okay. All right. Let's just do these two. Given f of x is equal equal to x squared minus 9, and g of x is equal to x plus 3. Let's go through and do these two, and then I'll let you practice. So let's do f divided by g of x. So f divided by g of x. So that's f of x divided by g of x. So f of x is equal to x squared minus 9, and g of x is equal to x plus 3. All right, so this is what scares me. I hope you remember how to factor. Do you know how to factor? Okay, well, you should know how to factor. I taught you. So I'm going to factor this, okay? So now before I factor this, though, we have to first look and say, is there a potential problem here for our domain? Do you see any problems? It's a fraction. So what is the problem with a fraction? What cannot be equal to 0? The denominator. So you're saying that x plus 3 cannot equal 0. Well, when will it equal 0? If we solve for x, that's when it will be equal to 0. So I subtract 3 from both sides. So x cannot equal negative 3. Does everybody understand that piece? Okay, now I need to continue. We need to simplify this if possible. So I'm going to see if it factors. So what I'm going to do is factor the top if possible. So I say what multiplies to be a times c. So what multiplies to be 1 times negative 9. Okay, actually, you know what? I'm trying to think. I mean, we have to factor this, but I'm just trying to decide if we're going to have time to do this today. Factor. I might just have you stop there, and then we'll finish up the factoring part on... But then you guys will get in bad habits of not actually finishing the problems, and that's what I'm more worried about. But none of the ones you do factor, actually, so I might just have us not factor. Okay, so we'll do ones that factor, because you will see ones that factor on Monday, so I'm just going to have you stop there. So does everybody understand how my answer is x squared minus 9 over x plus 3, and our domain is x cannot equal negative 3. I'll let you stop there today, but we have to keep going in the future. We have to. So we'll learn that Monday, though. We just don't have time on a short day. It just didn't hit me till just now that this can simplify. All right, questions on that one? We're all okay? Yeah, you're ready to practice on your own? Okay. All right, so do problems 1 through 6. All right, so everybody look with me on these, okay? Please look with me. So given f of x is equal to 4x plus 7 and g of x is equal to the square root of x plus x. Now, all of those of you that aren't listening, you're not going to be able to do the next problems. And I'm not going to answer questions to you if you're not listening. And I can tell when you're not listening, okay? All right, so f of x plus g of x. So f of x plus g of x. So that will be 4x plus 7 plus g of x, which is the square root of x plus x. Does everybody see how that's f of x plus g of x? Then we combine like radicals. We combine like terms, right? So we have 4x's plus 1x, which is 5x's. 4x plus 1x is 5x's. And then we have this plus 7, right? And then we have plus the square root of x. Think back to when you were adding radicals. Can we combine things like this? Can we add radicals to just regular old things? No. So this is the most simplified it gets. Now for my domain, looking at this problem, do you see any potential issues? Where is there a problem? The square root. We cannot have a negative under the square root. So you'll take that bottom part, and underneath there has got to be greater than or equal to 0. So I say x must be greater than or equal to 0, right? So that's our domain. X values as long as they're greater than or equal to 0. Because that's the only problem I'd run into. Does that make sense? Let's do one more. Couple more. Here we go. This is a good one. F minus g of x. So we know this is f of x minus g of x. So pay attention to the little details. F of x is equal to x plus 3. And then some of you are still making errors with subtraction. Then we're we're subtracting all of g of x. G of x is that whole thing. So we're subtracting the square root of x plus 2 plus 5. Is everybody good there? So f of x minus g of x. Now I'm going to distribute negative 1 through. Negative 1 times this is just negative 1 square roots of x plus 2. Negative 1 times positive 5, that's where most of you forget, is negative 5. So we have that, and then we still have our x plus 3. So then from there, we'll combine like terms. So x, do you see any other x's? So we still have an x. What's 3? Can we combine it with that negative 1? No, it's connected to this, right? Because technically, we just have negative square root of x plus 2. So we have positive 3 minus 5. Negative 2. Does everybody understand why that's negative 2? And then this is negative square roots of x plus 2. Is everybody okay with that? That's all we can combine. That is our answer. Now what's our domain? Where's the problem? Under the root again, right? So you're saying that this must be greater than or equal to 0. We can't have a negative under the root. So I'm going to go up to the side and say x plus 2, what's underneath, must be greater than or equal to 0. Well, let's solve for x, and that's where we're good. So solve for x. What should I do? Subtract 2 from both sides. So x must be greater than or equal to negative 2. If I plug in negative 2, what am I going to get? 0. That's okay though, right? We can have a 0. Does everybody see why that works? Any x values as long as it's greater than or equal to negative 2. So that's our answer. Domain is x values must be greater than or equal to negative 2. Anything lower than that won't work. Does everybody see how I did that? No questions. We're all okay. Okay, then do problems 7 through 12. These are the two places we have issues. So 7 through 12. What we really have here is 2x times by x to the, let's write it as a rational exponent. Roots are on bottom, powers are on top. So this is a 1 and this is technically a 2. So with rational exponents, that's 1 over, roots are on bottom, powers on top, roots on bottom. Does everybody see how I rewrote that? And then we have minus 2x. Okay, so these are not like this and this, but can we multiply not like exponents? Yes, right? So these are the same base. So when we multiply the same base, what do we do with our exponents? Add. So we do 1 plus 1/2, which is 3 halves, right? X to the 3 halves. Does everybody understand what I just did? I added 1 plus 1/2. If you do that on your calculator, because none of you really know how to add fractions, but that's why we have calculators. 1 plus 1/2 is 3 halves. So we really have x to the 3 halves minus 2x. So what we really have is, what's my root? Square, right? Square root of x to the third minus 2x. This would be considered the most simplified answer. Interesting, right? So you actually can combine those. I just wanted a side note of that. Does everybody see how to do that? I might require that on the test. Okay, awesome. You're all awesome. We'll stop there on the worksheet. We'll finish up the last of that next time.